Okay, before I talk about the voting for the competition, we're going to first do our poster previews. So this is something we started a couple years ago, or a few years ago. Instead of just, going out for posters, give you a little bit of like just one slide preview. They talk for just a few moments, attract you to come, see their posters out in the lobby area. So I'm going to ask the poster presenters, please come down, and we're going to go through each of these. Okay, first up, Juliana Dees, and I'm just going to say we're going 30 seconds or less.
So my project is predicting team performance in NCAA women's lacrosse. So even though the popularity of lacrosse has increased by 150% in the last 20 years, there have been very few studies about the drivers or the predictors of team performance, both in head-to-head matches and in team seasons. My study focused on the combination of possession stats, like save percentage, and just a combination of turnovers, draw controls in conjunction with shot percentage and shots on goal percentage, and found that using multiple regression and other studies, I was able to determine that these possession stats had the largest impact on team performance on a single season and in head-to-head matches.
Give you this one. All right, thank you. Next up, Josh Ekman.
Hi, everyone. I'm Josh. My project, essentially motivated by a desire to exploit mispricing in college basketball betting, looks at how well the line setting models in Vegas value home court advantage, and then looks at the factors that we commonly consider to create home court advantage and how relative or important each one is.
All right. Yeah, when you're done, give the mic to Kwong over there. Next up, Riley Fowler.
Hi, my name is Riley Fowler, and this is my co-researcher, Colin Kinzer, and we are part of the sports analytics team at Center College, which is a small undergraduate liberal arts institution in Danville, Kentucky. So for our project, we worked closely with the Center College football coaching staff, and using questions and ideas they gave us, along with Division III SAA play-by-play data scraped from the web, with the SAA being Center College's athletic conference, we developed win probability models and expected points models to help aid our coaches in game decision-making and hopefully win some more games.
All right, next up, it's a JPEG, so I gotta switch. Or PNG. Okay. Isaac Hershenson.
Hi, I'm Isaac. Is it on? Yeah. My project is on pressing in soccer and trying to give credit to players who close down space instead of making interceptions or blocks, which are rare events. So trying to value their off-ball contributions defensively in a smart way.
All right, thank you. Next up, switch back to PDFs. Do it live. Justin Hughes.
Hi, I'm Justin. Imagine your NBA team has 4 solidified starters, and you are trying to find your 5th player. You might be tempted to try to acquire the player that you feel is the most skilled. However, fit is important as well. Hence, we explore the interaction between offensive skill, defensive skill, and archetype among all 10 players on the court to predict the outcome of any given possession. This allows us to mathematically evaluate the effectiveness of any lineup, and thus, what player fits best in your 5-man lineup.
Samuel Jin.
Hi everyone, I'm Samuel and my poster is on identifying and quantifying spin moves in American football using player tracking data. So spin moves on the top are a type of technique that defensive linemen will use to get past their blocker and pressure the quarterback. There's been a lot of great research on quantifying lineman performance in general, but not as much on like individual techniques. So in this study, I first develop a framework to identify the spin move and then use techniques like machine learning and Sharp Value to look at the factors that go into a spin move. So if you're interested, please come by.
A high school student, as a reminder. Next up, Nolan Johnson. Et al. Lots of people from Center College here.
Yes. We are also from Center College, which, just as a reminder, is a D3 college from Danville, Kentucky. Our various projects are to demonstrate how we get raw data and then build it into our Shiny applications to help display this in a helpful manner to coaches and players. And we'll be displaying a few of our many sports analytics projects, including baseball, basketball, and volleyball.
Joey Kasanoff.
Hey everybody, I'm Joey, and my project is called Betting on Baseball with Machine Learning. So essentially, this is a project in predictive analytics. My goal was to develop a prediction model to beat the models used by PrizePicks, which is a daily fantasy sports app. So I use XGBoost to predict a pitcher's first inning pitch count. And then this project is essentially an overview of the hyperparameter tuning process, the feature engineering process, and then how to actually extrapolate insights from your model. So I'm really excited to present it, and thank you.
Gabriel Krokov. I will butcher last names. It's expected.
That's fair. You're not the first. Hello, I'm a student in the Master of Applied Data Science program here at CMU, and I spend a lot of my time mentoring robotics teams. Core problem, in the spirit of the first talk, what's the core problem we're trying to solve here? What if, in your sport, every year they threw out all the rules and wrote a new game? Some of you may be familiar with FRC. That's fundamentally the problem we're trying to solve. How do you, as a team, create models and data pipelines that will be able to serve you year after year, despite the rules changing under you all the time? Just for fun, one of the two teams I mentored, 6672 Fusion Core from Dallas, Texas, that's them competing in the finals of the World Championship in 2022. These approaches are some of our open source data projects, are what drove us to that success in 2022 and 2023. And if you're interested in doing robotics, come mentor the Girls of Steel in Pittsburgh, Pennsylvania. They're doing great. All right. Hope to see you at my poster.
All right. Next up, Riley Leonard.
Hello, my name is Riley Leonard. The title of my poster is Assessing Spatial Heterogeneity in Whiff Rate Using Geographically Weighted Regression. GWR is a spatial statistical approach that allows us to evaluate the relationship between parameters and a response in space. In this case, I evaluate the relationship between a number of pitch quality parameters and whiff rate based on the pitch's location. And yeah, I'm happy to share the poster later.
Next up, Dubin Melabodogu. Apologies for any mistakes I make.
Yeah, no worries. It's pronounced Dubum Beladaga. Okay. It's a lot less scary than it looks.
I try.
Yeah, I know. It's pretty phonetic once you actually look at it, but it's pretty scary. So yeah, my work is generating brackets for March Madness, and the general premise of the work is that there are awesome probabilistic projections out there, and if you follow those pretty closely, you'll probably do quite well in your bracket challenges. However, just given the sheer combinatorics of the March Madness problem, the most likely scenario is still quite unlikely to occur. And so I just wanted to see if there's a way that you could deviate from chalk and still outperform chalk year over year. And so I set the problem up as a bi-level programming problem and solved it using an asynchronous genetic algorithm. So if you're curious about how I set the problem up, want more details about how I came to a solution, or more details on the results, feel free to stop by my poster.
Next up, Paranjay Patil.
So in all sports, and in this case, especially football, the goal of a team is to win the championship, of course. But some teams will be content just making the playoffs year over year. So different teams have different expectations. So what we decided to do is to analyze second contracts that we're giving out to quarterbacks. And based on what the team is looking to do, they can adjust the parameters of the model and test for a different output.
Yeah, so we first checked for expected APY and things like that to see how much a quarterback should make in their second contract, and then based off of that salary in their second contract, how they would perform given that APY, things like conference championship probability, Super Bowl probability, and more. Come check out our poster if you have the time.
Jacob Pulaski.
Hello, everyone. My project takes a look at how MLB teams can change their outfield dimensions to gain more wins. As you can see, the Orioles and Tigers both did so in recent years, and they've experienced better winning rates. So to solve this problem, I fit a linear regression model that targets home win rate and predictor values of the dimensions of the field. And I discovered that the right center wall has the most significance, and it should be moved back to win more games. Thank you.
Raghavan.
I feel bad for having a confusing name. So sorry, Dr. Yurko. And also, I saw March Madness on your presentation. My heart sunk, but thankfully they're different. So yeah, the research that I do, I go to the University of North Carolina. And essentially, I'm sure you've all heard of March Madness. Well, we want to know, is there a method to the madness? Can we break that madness? So we analyzed what factors might contribute to a higher propensity for an upset. So we looked at both, on-court data, stuff like efficiency, stuff like assist and turnover ratio, but we also looked at the big picture: wins, win percentage, wins against ranked teams. And so, yeah, if you feel like you'd be interested, please swing by. Not only would be happy to talk to you about this, but also love to have some feedback. Always trying to develop the research. So thank you.
Gavin Shepard.
Hello. My name's Gavin. I'm a junior in high school from Northeast Ohio. My project's predicting future WAR in MLB. So first of all, what is WAR? WAR stands for wins above replacement. It's a valuable metric in determining how good a player contributes to their team. So I focus specifically on pitchers from the 2018 to 2023 MLB seasons, and I built a lasso regression and linear regression model to evaluate their future WAR.
He knows what lasso is in high school. Amrit Vignesh.
Hello, everyone. My name is Amrit Vignesh. I'm a high schooler based in Central Florida, and my project is focused around predicting the NBA MVP using 3 different models, which utilize machine learning and logistic regression techniques. I'm training data from 1980 to 2022 based on data availability. I'll be exploring the subjective nature of these accolades, and I'll be comparing the validity of basic and advanced statistics within basketball. And not included in the project, but I started applying the project to the current season. So I do have a current MVP predictor, which I'm trying to compare to Basketball Reference. So yeah, shout out to Dr. Yurko, shout out to everyone here. Shout out to my research professor, Dr. Sanders from Syracuse University. Thank you.
You started talking, it went into theater mode. I don't know what happened there. Yeah. All right, and Kellis Ward.
Hi, I'm Kellis. You might be looking at this and you might think that there's a pretty obvious answer, and you're not alone. The bottom race is part of a series that's marketed as the best way to qualify for the Boston Marathon. So my team and I set out to determine if there is actually an advantage that you gain by running a severely downhill race. And we propose potential adjustments to Boston Marathon qualifying times in order to eliminate that advantage. So if you're interested, feel free to swing by my poster. Thanks.
All right, let's give a round of applause for our poster. Make sure to check them out during the lunch break. So we're going to go.